Ah, yes. Gordon, I'm glad to see you made it. You see, I've requested your help because we have these factoring equations that we can't seem to solve. I've been on the line with the professor through a webcam, but we both seem to be having trouble. Can you help us? We have one that's factoring as a difference of squares, we have factoring a trinomial, and then we have factoring a polynomial. You think you could help us? Sure, I can help you. The first equation we see here, x squared minus 16, is relatively simple to solve. Since there are no common factors between the terms, that means that we factor it outside externally as much as we can. Now, the equation x2 minus 16, they're both perfect squares, so this means that the equation is a difference of squares. The formula right next to it, a2 minus b2 equals a minus b, a plus b, shows us how to factor it. Now, the two exponents for x are x, and then the obvious second term has to be 4, as it is the square root of 16. Note in the next slide how we double check our problems. Very good, Mr. Gordon. Our next equation is factoring a trinomial, but we cannot seem to remember how to start to factor it. Can you show us where we start? We have the equation 5x squared plus 50x plus 125, but we're not sure where you start to factor it. Thank you. Now the first step to factoring a trinomial is to find the greatest common factor. Now the greatest common factor is the largest number that goes into each of the terms. In this case, it happens to be 5. Now, once we divide each term by 5, we get the following equation. 5 and then parentheses x2 plus 10x plus 25. This is what it's supposed to look like. Notice how each of the terms on the end of inside the parentheses are still a perfect square. This means that there's a formula much like the last one to help us factor it easily. The formula in this case happens to be a2 plus ab plus b2 turns into a plus b times a plus b. Yes, but Mr. Gordon, we have one last equation for you to help us solve. It's factoring a polynomial, and in this next equation we will see how complicated it looks. We have an equation ab plus 7a plus 5b plus 35. How do we solve that? It's simple, Professor. First we address the equation. Obviously there are no greatest common factors among all the terms, so this means that we must divide it into two separate terms and factor each separate term, turning it into a binomial. Let's address the first one, ab plus 7a. Now, we can factor the 8 out of this, as there is an a in each of the terms. We get a parentheses b plus 7. Now we can move on to factor the second equation, 5b plus 35. Now there's a 5 in each one, so now we factor it to get 5 parentheses b plus 7. Now here's where it becomes interesting. Because we have two factored equations, each of them end in b plus 7, this means that we can combine them and combine the a and positive 5 to form a complete another equation, turning it into a binomial. This is a factored result of the equation. Ah, yes. Thank you, Gordon, for your help and taking the time out of your day to come and solve these problems with us. Now I really must be going.